welcome back, everyone. Now we have a talk with Stefan. I'm not sure I can say your last name. Maybe you can help me. Baumgartner.
Yeah, very good.
Thank you.
Very good.
Thank you for being with us. I know that you are from Austria, right?
Exactly, yeah.
So how are things there? I think you are one of the best countries in Europe regarding the COVID-19, right?
We kind of made that right. I don't know how it happened, but people were really good at staying at home. So this is apparently a survival skill today, and we are now opening up restaurants again and shops, and slowly but steadily, it looks like we're getting back to normal. It's a different kind of normal than it was before, but and it kind of feels weird. After 3 months of isolating and being locked down, but you see the people are opening up. Not only the shops, but also people are opening up, and I think this is a really nice gesture. So I'm looking forward to see what's happening in the upcoming months. So
yes, it looks very similar actually to Portugal. So yes, let's get back to the almost normal way of doing things.
Yeah.
So, Stefan, again, thank you very much for being with us. I will let you start. It's over to you now. Thank you very much.
Very good. So, first, thank you so much for having me. I'm feeling incredibly honored to be invited to a conference that has its roots as a Java conference, because I just don't know Java at all. Everybody around me in Linz does Java, so we are a very Java-heavy city in terms of software engineering. There's even some people from Oracle developing a new Java compiler out there, and I'm here, the JavaScript guy. I tried Java for a while back in the 1.4 days. Let's say it didn't work out, so we're separated now. It's okay, we don't talk about it. That's the best for both of us. But still, being invited to a Java conference or a conference that has Java roots means a lot to me. This is a huge privilege. So thank you so much. We just briefly talked about COVID-19, and let's say 2020 is terrifying. It's hard. It's been quite a year so far, and we are just halfway there. The last months have been extraordinarily difficult for all of us. And I don't know about you, but especially the last weekend was extremely difficult for me to process. And I'm going back to that later on. But of course, we are here online today because of COVID-19. This disease is already scary enough. We just don't know too much about it. We know it's dangerous, it spreads, and there's no cure for it, at least not yet. And the fact that the disease looks like this one Jira ticket that you can't close doesn't make it any less scarier. In fact, who thinks we're going to reopen the ticket in autumn? I don't know. I don't want to be there. But also, when living through such a pandemic, it brings a lot of things into perspective. And it makes other things look utterly ridiculous. So, one example, my receding hairline that keeps bugging me ever since. Maybe I don't think as bad of it anymore. Maybe I think of it as a way to look as cool as Captain Picard, and who doesn't want to look as cool as Captain Picard? Another thing that was a topic that people can get really upset about is using semicolons in the code or not. And you know what? I drop semicolons all the time. It's liberating. And I do it manually. Don't judge me. Don't judge me. And it also should end the ridiculous discussion of good versus bad programming languages. First, it's a stupid discussion altogether and wasted energy. Use this energy for something much, much more important, like fighting Nazis. That's much more useful for the rest of the world. And also, just because a programming language doesn't work the way you think it should, doesn't mean it's a bad programming language. And yes, I'm talking about those people who focus so much on the Java part of JavaScript. And this is, for me, absolutely annoying. Those same people, back in the day, advertised TypeScript to me as JavaScript for Java developers, because we have classes and we can inherit from stuff and all the things. And this is something that put me actually off of TypeScript for a long, long time, because I was a JavaScript developer and I loved working with JavaScript. And it wasn't until I saw Anders Heilsberg, the lead architect of TypeScript and one of its creators, that I found appreciation for TypeScript. When Anders Heilsberg talks about TypeScript, he doesn't talk about making a programming language that gets rid of all the quirkiness or difference in JavaScript. He talks about it as some additional layer of tooling on top of JavaScript. He talks about the design goals. He talks about its strong relation to JavaScript, and you can feel that. And coming from Anders Heilsberg, this is no wonder. Anders Heilsberg has always focused on making programming languages wonderfully usable. When you look at Turbo Pascal, it made programming fast. Back in the day, you had to swap tons of diskettes to just make your code compile and to run it for the first time. A compile cycle took 30 minutes until you found your error. And then you had to go into the debug phase. And Turbo Pascal just integrated everything to bundle together with a nice editor. And you were able to code immediately, find errors immediately, and get immediate feedback. That's where this turbo comes from. The same with Delphi. Delphi made Windows applications easy to program. Look at the editor. Editors are still inspired by what Delphi did back in the 80s. Same with C#. C# lives from the whole tooling and editor experience. It comes bundled with, when you have Visual Studio, for example, you can write C#, you have your database applications with it, you can write web applications with it. Everything is integrated, everything is bundled together, everything works out of the box. And those were also the design goals for TypeScript. This is from the Strada design document back in 2011. That's more than 9.5 years ago, where they said, okay, we want to be tooling for JavaScript. Tooling was one of the main and major goals of creating TypeScript. And also regarding language, they just want to do language innovation where it's critical to the Strada goals, which is now they don't do language innovation at all anymore, because JavaScript went into a really, really good process of getting new language features. Just like Roy said today in his talk earlier, that all the new JavaScript features you get in TypeScript. In fact, the TypeScript team is part of the TC39 standardization committee and plays a major role into getting new features into the language. And before they land in browsers, you get them in TypeScript, which is cool. If you're still not convinced, I can highly recommend watching this video from Anders Heilsberg and Lars Bach. Anders Heilsberg, creator of TypeScript, Lars Bach, creator of Dart, both at the same time developing languages that transpile or compile to JavaScript. Lars Bach having the goal of creating an entirely new language, entirely new syntax that compiles to JavaScript, whereas Anders' idea was to create a language that evaporates to JavaScript, for lack of a better word. It just disappears and JavaScript is left. And when you hear him talk about this programming language, he talks about tooling. TypeScript is first and foremost a tooling layer. So for me, this means, and this is what brought me to TypeScript in the first place, TypeScript is JavaScript. And if you're not convinced by that, look at the website. It says so on the website. TypeScript is JavaScript. JavaScript that scales, yes, but it is JavaScript. And I wondered, if TypeScript and JavaScript are so closely related to each other, can we see that while we are coding TypeScript? Can we see through some behavior of TypeScript? Can we see JavaScript shine through? And this is what I set out to find out. And this is what brought me to lots of realization, not only about some behavior in TypeScript, but also about stuff in JavaScript that I didn't know. I've been using JavaScript now for almost 20 years. And by using TypeScript, I still learned new things about this programming language. I'm now switching to my editor. And there you go. Here I am. I hope you can see my editor now. If you don't, I'm sure Samuel will get back to me. Let's start with this simple function. It's a function saying I have no return value. It takes any argument, logs it out to the console, and returns nothing. It returns void. And if you know other programming languages, I'm very sorry. If you know other programming languages, void means having no return value, which also means that you can't assign the return value of this function to a variable. But if we do that in TypeScript, like const return is I have no return value with anything, let's say 2, it compiles. We don't get any red squiggly lines. And if we hover over return, we see that return gets a type. It gets void. So return is now a value that we can work with. Well, it has no type. It has the type void. It might have no particular value, but we can assign the return value even if it's void to a variable or to a constant. And this is because in JavaScript, every function returns something. Even if you don't put a return statement in there or return a value, every function returns something. In case of this function or of many other functions, they at least return undefined. So void is, in TypeScript or in JavaScript, a fancy way of saying undefined. Let's just, let's take this function for instance. So if void is a type and void can be a value, I can also use it as input value. This function I take name parameters takes just x, which is void. So what are we allowed to pass? I am so sorry. What are we allowed to pass to it as argument? So I call I take no parameters. This works. Okay, I take no parameters. I don't pass anything. This works. I can't pass 2 because 2 is not in the same type space as void. And I can pass undefined. Undefined compiles because undefined and void are very similar to each other. And this is also where we can use, for example, JavaScript's void. Yes, JavaScript has void in the language. I can write void 2, for example, and it still compiles. Void has a special meaning in JavaScript. With void, you make sure that no matter what comes afterwards, on this position where the cursor is right now, comes undefined. So no matter what you do, no matter what you execute, no matter what's coming afterwards, void makes sure that there will be undefined. And there's some very interesting use cases for that. There's even more. Let's go to the next example. This is a function that accepts a callback, and it accepts a callback that returns void, which means it returns nothing. As you can see here, with C gets void as type. If you call the callback, it gets void as type. So big question, if I write a function that looks like this, a number callback that returns a number, can I use this callback here and do something? Let's try it out. A number callback. I can. It compiles. No red squiggly lines. This is because, so if you can see here, this method signature is entirely different from that one. It returns, this one returns number, this one returns void. But this is one of the particular things in TypeScript where they try to comfort what's happening in JavaScript. There are so many callbacks that don't accept any return value. But in reality, when you're using JavaScript, you pass callbacks that return something. This is why TypeScript allows you to substitute functions with a different method signature for functions that use void as return type. So the reason for that is that when you use it in here, inside here, you still can't do anything with C. So you can't say console log C+2 because it's void and you can't add to void. So you get the compiler warning there. But as long as you don't do something with the value, you can pass any callback that at least has the same arguments, doesn't have to have the same return value. We can change it if we say, okay, this function has to return undefined, and suddenly this callback doesn't work anymore because number and undefined are not substitutable. But void is substitutable. So this is the special thing with void. You can use void and can substitute other types for it. Same with this example. So this is if you go into substitutability, there's more to it. This is a fetch results function that also accepts a callback, and the callback needs a status code, a number, and the results a number array and returns void. So we call it like that. Callback is 200, a status code, and the results. I can now use this function handler that just accepts the status code and just accepts a number as the first argument, and I can use it together with fetch results. This compiles, and this compiles because, again, substitutability in TypeScript. Even though I pass multiple arguments and the method signature is different from what we have here, as long as we don't do something with those arguments, it's totally fine to substitute this method signature for this one over here. The moment I pass here an argument, let's say results, and I expect a string array, I get error messages again. This is great. It has to be number, or it has to disappear. And this is also because, you can pass as many arguments to a function as you like. In JavaScript, you can pass all the arguments into it. Doesn't matter. The function just works with the arguments it can name, it can work with. And that's why we are allowed to substitute functions with a different method signature with less arguments for functions that have a wider method signature. This is all part of structural typing. So here, not the shape of it is important, but the order of arguments. But as long as we match parts of it in order, we are allowed to use it. And this is due to the flexibility of JavaScript and TypeScript trying to be as comfortable for JavaScript users as it can be. Next example. Now we go into some object-oriented programming. Let's open example 7. So this is something that you see probably all day. We have an abstract class. It's a filter item. It takes a constructor. It has a couple of functions, and the filter function should be implemented by other class. For example, this one and this one. So two classes, they implement. So think about the implementation yourself. Doesn't matter. But they implement this filter item. So here I have constant width, which is a filter item, and I initialize it as a new a filter. So this works as intended. So this happened some time ago in a project that I was supervising, where we tried to create the map of all possible filters that we have. And adding an identifier like a number filter, it's a stuff filter, whatever. It's a map that it's a generic. We say keys or string, and we get filter item, type of filter item to it. So we can set those filters, which is good, and can then retrieve those filters again once we need them. So I fetch the constructor filter map.get number. There we are. And if the constructor is not null or undefined, then we say const object is new constructor. Bam, this doesn't work. And of course it doesn't work because what we are getting is an abstract class, okay? And we can't make an instance of an abstract class. This is we know that. This is not something that's new to us. So what we think of maybe is getting some interface. So there's an interface. This is the TypeScript way of saying we need a constructor. It has all the functions that we know, and I say, okay, instead of having a filter item, I have iFilter here. Bam. Looks good, doesn't work. So suddenly the filters are not compatible anymore with iFilter, even though the structure is kind of the same. So we might want to fix that by saying it implements iFilter. But then we see, okay, a filter item doesn't actually implement iFilter. So this is something that's entirely different because it lacks the constructor, but the constructor is here. So how can it lack the constructor? What is happening here? Let's move that again. And the reason for that, and this is something that I found wonderfully interesting. Let's look at what we had before we had ECMAScript classes. We had something like this. This is not really important, and this property here is a string. Before we had classes, we had prototypes and constructor functions. So this is a constructor function called cFilter, and this is part of the instance. So cFilter, prototype filter, cFilter, prototype something. And the moment you say, okay, new cFilter, hello, you get an object that has everything inside this prototype. So this is a way how we did that previously. This for some reason doesn't work. Maybe I have an error here, but this was how we were creating objects back then. Creating a function, a constructor function, then creating the according prototype to it. And if you look at that, this is actually two different types. It's not one type, it's two different types. It's a type for the constructor function, and it's a type for the prototype. And this is also what we need when working with patterns like that. When we want to separate what we have in the constructor from what we have in the object itself. So let's go to a correct implementation. So instead of having everything in one interface, we create two interfaces. One is the interface, the filter constructor, which creates a new iFilter, and the other one is the actual object then. And now I implements iFilter. I guess this should work now. Type of iFilter. Something doesn't work here. Maybe I have some problem. Sorry, no, I don't have a problem. I just forgot something. So I have a filter constructor that creates iFilters, and I have this new iFilter. So here I add filter constructors to my map. And I have to pass an argument here because it's a string. But suddenly, the moment I pass filter constructor, you get a filter constructor out of it. And when we create this new instance of it, we know that it returns an iFilter. And then suddenly object is iFilter. And I can use those functions. And this is called the constructor interface pattern. Because previously, classes somehow existed in JavaScript with the constructor function and the prototype. And classes today are syntactic sugar for what we had previously. That's why we need two types, because it was two parts of a class back in the day. And this is also, again, where structural typing kicks in, which is pretty cool. I don't have to say that it is of type filter constructor or of type filter iFilter or whatever. It just has to match. So iFilter matches definitely the filter constructor because it has this constructor and it implements all the functions that are required by a filter constructor. The moment I, for example, say something new here as well, I get problems because it doesn't implement that stuff. All right. So constructor interface pattern, something that I learned when working with TypeScript about JavaScript, because yeah, of course, we had constructor functions and prototypes. This makes sense. Something very interesting. I don't know if you know all the primitive types of TypeScript, but there is, of course, string, number, Boolean, object, and symbol. And symbol is very interesting. So I can create a new symbol. It's a symbol. And let's say it's a new symbol and some description. A description, this doesn't matter. Okay, maybe it does. And maybe I just have to remove the new. When you have over XX, it's of type simple. Usually TypeScript has type inference, so I can get rid of the simple keyword. If I do so, you see that XX has a new type. It's type of XX. And this is something very interesting. I didn't work a lot with symbols. I just learned them through TypeScript. Symbols in JavaScript, when created that way, are absolutely unique. The moment you call the symbol function, you have a unique value you can use, which is not comparable, not substitutable for any other value that you have. It is an entirely unique symbol. And this is also something that TypeScript declares like that with the unique keyword. So we have the unique keyword and can say you are a unique symbol. And then you get again type of XX. So it's unique, which means that if I have YY, which is a symbol, and there's an XX to it, this works because it can be any symbol. But if it also should be a unique symbol, I get an error because it can't be assignable. It's totally and entirely different. It's cool. So symbols are really cool if you want to do like have methods in your objects that you don't want to iterate over. For example, you have an object, const opt is it has a name, Stefan Baumgartner. It has an age, 38, entering midlife crisis, dropping semicolons everywhere. And then we have a function that prints out that stuff. And they say, okay, use the global symbol for print. And this is a function. And I can say console log age. Doesn't work here. This.age, of course. And this.name. So it's not iterable, which means I just get those properties, but I can access it again with the global symbol for, symbol for print. No, I can't, because it is not available. It simply can't be used as an index type here. Anyway, this doesn't matter. You can do cool stuff with that, like something like this. You can define types like modes, prod mode and dev mode, which is a unique symbol for production mode, unique symbol for development mode. If you want to use it in your code, like with here with show warning, you can create a mode that is either type of dev, type of prod. So getting to the symbol value again just works with the type of operator then. And then you see, okay, this mode is either type of prod or type of dev, which means you can say show warning. Stefan's code didn't work. And say dev works. You can see prod works. You can't create a new symbol because this doesn't work. If we say, okay, we don't matter, we just want to have one symbol, then you can use the symbol again. If you say unique symbol, you have to be very specific which one, so you can't use that in method signatures. There you have to use that one. Do I have another? Here, for example, this is how we can use symbols. Otherwise, you just want to extend that object. You say object of sim is this value, and you pass the symbol along with that. You can use here different symbols as well. Hello, or you can use some unique symbol that you defined. So this is the difference between symbol and unique symbol. Unique symbol because all symbols are unique. All symbols are entirely different from other symbols. If you don't care which symbol in your methods, you can use symbol as a type itself. If you care which symbol you want to use, you can use unique modifier while creating it. And you can use type of to retrieve the actual type. And symbols exist in JavaScript. Okay, so this is a quick overview of what I've learned when working. Oh God, sorry about that. Here I am. You can see my screen again. Those are some things that I learned while working with TypeScript about JavaScript. Here are some resources on that. So I blog a lot about TypeScript on my blog, Fat Blog. You get infos about the interface constructor pattern, about symbols, about void, about Boolean. I'm now preparing an article about this. And if you learn one thing today, then it is that TypeScript is JavaScript. It is JavaScript with benefits, which is cool. But this also leads me to a way of writing TypeScript that is very, very close to JavaScript. So what I do is I write modern day JavaScript and annotate when necessary. Usually I do type annotations only in function heads and the sweet turn types, so I know everything makes sense what I do. I don't do any type annotations at all. So you come out with a really, really small layer of types. You create some interfaces, you create some union types, you create some string unions, and you annotate your function with that. You should be good. You rarely have to annotate your variables or your constants. Work with return values. I also stick to TC39 language features. I try to avoid non-TC39 language features because what is in TC39 sticks with the language. TypeScript turned over the whole module system at some point in time because JavaScript got a module system. TypeScript still runs decorators under experimental because they still haven't decided how decorators should be implemented in JavaScript. And this might change. So especially if you're an Angular developer, the way you write decorators might change in the future because browsers might implement it differently. That's why I stick to something that is already stage 3 in TC39. Stage 3 meaning safe to implement, safe to use. Stage 4 means shipped. And TypeScript is one playground of TC39 stage 3 features. So the moment features arrive in stage 3, TypeScript is implementing that. And for the case of, let's say, the optional chaining argument, the question mark you can put after object properties, this is something that kind of landed in browsers and in TypeScript around the same time, just with a couple of weeks, a couple of months time in between. Very cool. I try to avoid stuff that kind of is not only type system and not only programming language, stuff that is kind of both, because I never know what I get. So abstract classes, for example, or something like that. Enums or something like that. Classes aren't. Classes are JavaScript feature, just the way you used it. Decorators should be in JavaScript at some point. And then I'm happy to use them as well. But hey, those are all recommendations from somebody who loves to write JavaScript and finds himself in TypeScript. There are many, many more important things that you should learn today. I think we, as software developers, have the power to change the world for the better. And that's why I want you to stop talking about tabs versus spaces or good programming languages versus bad programming languages, or if you want to use semicolons or not. Hint, it can be liberating not to use semicolons, but that's not something we need to talk about. Let's talk about something where we really can make a change. We have extraordinary skill at software developers, and we can take our skills and do something useful for society. We can use something for people who are in need of help. And every action that you take, every code that you write, every statement that you make, please validate it if it's something useful for the society. This is our application. This is our responsibility. And I think this is our duty. And with that, I want to thank you. If you want to read more from me, listen to more from me, want to go to one of my conferences when they are up again, if COVID-19 finally goes down for good, hit me up on Twitter. I'm @parrot on Twitter. Thank you very, very much. I'm open for all your questions.
Thank you, Stefan. Super interesting talk. Everyone, if you have a question for Stefan, please drop it on the YouTube live stream or in our Slack channel, and I will be happy to pass it to Stefan. So let's see if we have a question for you already. Not yet.
Not yet.
But we have a small delay between live and YouTube,
So they're still hearing me talk about semicolons there. The thing is, everybody tells me I should install Prettier. Yeah, I know, but it's not as much fun.
Yeah.
And I freak people out if I run over code and just remove.
I think
semicolon
after you say that you don't use semicolons, everyone have left the room. Probably.
Yeah, most likely. I'm very sorry. Don't judge me. I'm an old guy. I'm starting midlife crisis. I have a Twitch account. I started using React. All those things kids do, which also means I stopped using semicolons after 20 years of programming JavaScript.
So have you considered moving to other language that don't use semicolons from the start?
Actually, one language that I'm very interested about is Rust. And I honestly can't say if it features semicolons or not, because at the moment I just don't read them anymore. The thing is, I'm at the moment I'm very happy with TypeScript. So TypeScript is when used as this typing layer, it's really liberating on how much info that you get. And this is, I guess, something that's important to think about when using TypeScript. TypeScript has language features that are just there to make more sense out of JavaScript. And if you know the flexibility of JavaScript, you can have a function where you can pass anything into it, and all the logic inside that function can have a totally different outcome than you would expect, because you just drop any arguments in, and the function decides what to do with it, with lots of type checks, lots of value checks, whatever. This is the flexibility that we get with JavaScript, and finding a type system that can understand this behavior. This is incredible. This is something that's really masterful if you have to develop type systems. And this is how they came, for example, to conditional types. Conditional types where you have a type that can change its form depending on what it gets as an input, and having inferable types for that. This is just plain crazy. But this is how JavaScript works. And this is so great that people are thinking about all the different cases that JavaScript can take on and try to make something that documents this in a type system. And this is how great this programming language is. And if you think about it from that way, and not from this way that it's JavaScript for Java developers, you have much more fun with it.
And it's growing and growing, right?
Yeah, absolutely.
You say that you have started using React. So are you using React with TypeScript already?
Yeah, exclusively. It's funny because it's, I guess, the one framework right now that isn't written in TypeScript, but it still has the best TypeScript support of all of them. So the types are so solid and so fun. And when you use JSX inside of with TypeScript, you get autocomplete for your templates, if you will, which is so not because of some plugin or something, because of how React works and how TypeScript works, and that React element is nothing but a function call, and TypeScript is nothing but something that tries to understand function calls. Match made in heaven. So from two totally opposite sides, they understand each other so well, because both TypeScript and React focus on JavaScript, and this is great.
And in terms of documentation, is there documentation for you to use TypeScript and React?
Yeah. So there is no official documentation, but if you go to my blog, Fat Blog, this is actually one of my most favorite articles, and the one I constantly get feedback about. I tried to have a side-by-side comparison between the React documentation and what you can do with TypeScript. So you get the TypeScript information on my blog, fatblog.eu/TypeScript-React. It's a guide about 10 pages where you see which types you can use, how you can, which generics you can use, which types are available, which one can be inferred, especially when working with hooks, how you can implement different design patterns in TypeScript and what you need to take care about, and also how you can do basic styling. You know, there are lots of styling solutions out there for React, like using the style property, using style JSX, or using emotion or style components. And I looked at that as well, so that you find some pinpoints, you know, where you can look up how to use that in TypeScript in case you get a red squiggly line and don't know where it comes from.
Okay, nice. I wasn't aware of that. Need to look myself into your website.
You should. Spoiler, next week I'm going to relaunch the whole website. It's going to be a lot more colorful. It gets all the gradients, and I try to at least publish one TypeScript article per week. So definitely worth to checking that out.
Okay, so Stefan, it seems that I was the only one with questions because we don't have any question for you. We have, however, people saying thank you for your presentation, which was very nice. Thank you.
Thank you very much for having me. It is a privilege, really. It's wonderful to be here.
Thank you. I hope to see you again soon, maybe in a future edition of G-Nation.
Yeah, and hopefully face-to-face
in Portugal
at the same spot. That would be great. That would be terrific.
Yeah, thank you very much.
Right, folks.
See you guys.
Bye-bye.
We are coming back in 90 minutes. So see you.